when you are finding the area between two curves, you are setting up a definite integral. X goes from the lower limit to the upper limit. Usually this is where they intersect. So from a point to another point, and then you are using the top curve minus the bottom curve in the integrand, and then dx. Now, the biggest question that I want to answer is, why do you use the top minus the bottom? How come you don't use the top plus the bottom? How come you don't use the top multiply or divided by the bottom? Why do you use a minus? So I'm going to tell you why in this video using this example. So I am going to use two functions. The first one is a straight line, that is y equals to x is a straight line, and then the next one is a parabola, y equals to negative x minus 3 squared plus 9 in blue. So the area between the parabola and the straight line is the yellow region. What I am trying to do is I want to find this area. I want to find what the yellow region equals to. Tell me what the area equals to. And this yellow region is equals to the blue region minus the red region. So the blue region, now without, let's don't go to the blue region yet. Let's go back to the first picture. So in the first picture, do you see that there is a yellow region? Now in this picture, it is clear that the parabola is on top and then the straight line is on the bottom, right? Let's do this again. The parabola is on top, the straight line is on the bottom. That is very clear. So we will be using the parabola, which is the the blue region, minus the straight line, the red region. The parabola is on top, the straight line is on the bottom. We are trying to use the blue region minus the red region. Now let's take a look. The area under the parabola from 0 to 5. So from 0 to 5, so this is a 0, this is a 5, right? So if you are setting up an integral from 0 to 5, and then the integrand, you will be using the parabola, and then do we agree that the area is equal to the entire blue region? It's pretty big, right? And then hold on to that, and then for the straight line, and then we are going to set up an integral from 0 to 5. So I should write this down for you. So this is from 0 to 5 of the parabola, and then this one is from 0 to 5 of the straight line, so x and then a dx. So that gives you that red region over there. Now you have to do this in your mind. Look, if I take the big blue region and then I subtract the red region, do we agree that is equals to the yellow region? Look, blue minus red is equals to yellow. One more time, take a look at the blue, subtract the red. That means you are taking the second picture. So you are taking this second picture, and then you take out the, do you see that? You take out the red, you take out the triangle, you take out the red triangle. Do we agree that if we have a blue, we take the triangle out, then we get the yellow? So that's why we have to take the top minus the bottom, because the region on top is so big. The bottom is like an extra, so you take the big minus the little extra, you trim the big region, and then you will get the yellow region. So that's why we have to do a minus, not a plus, not a multiply, and not a divide. Okay, so what is this area equals to? I have integral, and then from 0 to 5, top curve in blue, and then the red, and then the bottom curve in red. For this definite integral, you will have to expand the whole integrand. So the first step is you will have to expand the, I'm going to follow the color. So before this, so before I start in doing the integral, so do we agree that we can break this down into two integrals? The first one is from 0 to 5, and then we have negative x minus 3 squared plus 9, right? Plus 9, and then dx, and then we minus, let's do that in red. So we have in red, that is red. So from 0 to 5, and then x dx, and then we are subtracting this. And then what do we get? I already did the math for the blue integral, that is equals to 33.3. And then the red integral, that is equals to 12.5. So that is equals to 12.5. When you subtract them, what is the area equals to? The area is approximately equals to 20.83. So that is the area between them, between the two curves. Okay, so this is an approximation because the 33.3 is an approximation. Now, let's break down the integral. So I'm going to break down the entire integral. Let's see. Let's break down the blue piece first. All right, so you are subtracting the whole thing, then you have a negative x minus 3, right, square plus 9, and then you are subtracting x. So you are subtracting x. So that is what we are trying to simplify. So first of all, let's clean up the parentheses. So we have a minus, so that is equals to x squared minus 6x plus 9, and then the rest plus 9 minus x, and then you distribute the minus, so you have a minus x squared plus 6x, and then a minus 9 plus 9 minus x. I can see that the two 9's got cancelled, so you have a negative x squared plus 5x. So that is what you get after you clean up the integrand. And then you go like this, from 0 to 5. Actually, you know what? That looks like I am working for the blue area. So I'm going to change my color a little bit. I'm going to change my color to back to orange. So this is from 0 to 5, negative x squared plus 5x dx. What do I get? So I have a negative 1/3 x to the third, and then plus x squared 5 divided by 2 from 0 to 5. So for this, if you take the derivative, you can simply get back to the integrand. Plug in 5, plug in 0. So you have a negative 1/3, and then plug in 5 to the third, plus 5 over 2, plug in a 5 to the square. So this is the upper limit, and then the lower limit, everything goes to 0, right? Let's write that anyway. 0 to the third, and then plus 5 over 2 times 0 square. So this overall, that gives you, you can just do an approximation. So that is gives you approximately equals to 20.83. So this is the area between curves. So area between two curves. That is the area between two curves. So the 20.83 equals to, so you start at this line, and then you clean up the integrand, and then you integrate, you will get 20.83, which is equals to the yellow region, the area between the parabola and the straight line. And then I know that is the end of this problem, but I want to tell you another what if. So what if the question gave you two curves, no graphs, nothing else. They give you two curves, a parabola and a straight line, and then they say, okay, find the area between these two curves. And you don't even know what the intersection is. First of all, you graph them, you find out which one is on top, which one is on the bottom. You have to do the graph, okay? You have to do the graph, you have to look at the graph to find out which one is on top, which one is on the bottom. It is just hard to tell without a graph. And then the next thing is, how do you find the intersections if they didn't tell you? So the intersection, I'm going to do the math right over here. So let's say they didn't tell you anything, then you have to find the intersection. So all you have to do is you set the two functions equals. So plus 3 squared plus 9. So this is the parabola. You set that equals to the straight line. Because they intersect at 2 points, you should get two answers. And then this is negative x squared plus 6. This side is equals to x. And then you have to move everything to one side and then solve for x. So negative x squared, this is 6x, plus 5x equals to 0. And then you take the negative x out, so and then you have x minus 5 equals to 0, and then you have x equals to 0, and then x equals to 5. That tells me there are two intersections, one at 0, 0, and then one at 5, 0. Oh, by the way, sometimes finding the intersection is very difficult, depending on how complicated the two functions are. Alright, so that is the end of this video. If you like the way I teach this, you like my explanation, give me a thumbs up, subscribe, stay tuned. I will see you all in the next one. Signing out.